Okie dokie. Last thing we need to do is find out where we can use some of this fun exponential growth and decay in some of our real world problems. So here are a couple formulas you need to know. This one, A equals P times 1 plus R over N times to the power of NT, is going to give you if something is compounded n times year. And then if you have continuous compounding, that is your PERT equation, is what I call it, because that's just A equals P times e to the power of RT. Now, I will give you these equations, but you need to know what P represents, A represents, R, N, and T. A is your balance of an account after so many years. In fact, after T years. So T is years, and actually it could end up being in months, days. That may change a little bit. So T is going to be your time. Principal P is just what you start with. So that's going to be whatever your starting amount is. Annual interest rate is R. Now this is in decimal form. So if you are given like an 8%, that means as a decimal, you write that as 0.08. And then finally, N is your number of times compounded year. Now if it's compound continuously, that is where you use E. You don't have an N. But otherwise, you're going to use like N's for monthly, yearly, and all that fun stuff. You're going to plug those values in. So if we look at example 7, it says here we have a total of $4,000 is invested at an annual interest rate of 5.25%, compounded monthly, so this is not continuously, so it's compounded monthly. We need to find the balance after 6 years. So since we are compounded monthly, we need to use the formula A equals P times 1 plus R over N to the power of NT. Well, we're trying to find A, so we're going to solve for that. P is how much we start with, so you get 4,000. Then you have a 1 plus, now since it's compounded monthly, that means that R is equal to 12. There's 12 months. We're going to take 12, your rate, we need to do that first. 12 is going to go underneath here for your N. Now your rate, since it is 5.25%, that means that as a decimal, that is a 0.0525, and don't round that anywhere, but you actually have to use that 0.0525. And then you have your N on the outside, which is 12 times 6. So when we simplify this, you get 4,000 times on the inside, we'll figure out what that is, and 12 times 6 is 72. So if we have on the inside 1 plus, and then parentheses 0.0525 divided by 12, what we're going to do is we're going to round to 4 decimals. We're going to write this as a 1.0044. 1.0044. As a general rule here, let's just multiply or round everything to 4 decimals. So when we plug this into our equation, this should give us our value after 6 years. Now make sure you do not multiply 4,000 times the 1.0044, then multiply that, take that to the power of 72, because then you'll get an astronomically large account balance, which would be nice, but unfortunately is not realistic. So we're going to take 4,000. And you can type it in just exactly how it's written, 1.0044 to the power of 72. So after 6 years not touching the money, what happens is you get, now this you're going to round to 2 decimals. You're at $5,487.10. So $5,487.10. That is your solution. And that's how much money you're going to have in the bank if it's compounded monthly for 6 years.